Hello again, and welcome to the Algebra 1B semester exam review. This is page 4 of the second review packet. And this video will cover questions 11 through 17. Okay, question number 11 is asking you again to solve the system of equations. And we've talked about that a couple of times already, that when you're asked to solve a system of equations, you can use either substitution or elimination. It's totally your choice. Once again, I have questions 11 and 12 that are both asking for the same thing. So I think maybe I'll do number 11 with substitution and 12 with elimination, just so you can see the difference between the two. Okay, so in number 11, if I wanted to use substitution, the first thing I need is one of the variables by itself somewhere. It doesn't matter if it's x or y, and it doesn't matter which equation it is. So I'm going to look at this second equation here, where x and y already don't have numbers in front of them. They don't have any coefficients, but I do need to get one totally by itself. If I took this y and added it to both sides, that would turn this bottom equation into x equals y plus 5. And now I have x alone, which was my goal. Now I can take what x was equal to, which is y plus 5, and put it in place of x in the original equation. Now I've noticed some confusion in class about which letter to plug that in for. Do I plug it in for x? Do I plug it in for y? And the problem is there's no set rule. It depends on which variable you got by itself in this step. So I can't tell you that it always goes in for x or always goes in for y. You always plug it in for the variable that you solved for. So here I solved for x, that's why I'm plugging in for x. So I'm going to take this top equation now and rewrite it. The equation right now says 2x plus 3y equals negative 10. I'm going to write it exactly like that, but instead of the x, I'm going to write 2 times y plus 5 plus 3y equals negative 10. Okay, and then distribute this 2. So that would give me 2y plus 10 plus 3y equals negative 10. Okay, from here I'm just doing equation solving. This is the same equation solving that you saw way back at the beginning of the year. So here I would combine my like terms. 2y and 3y makes 5y. Plus 10 equals negative 10. Then I would try to move this 10 over to the other side because remember now my goal is to get y by itself. So let's subtract 10 from each side. 5y equals negative 20. And then divide both sides by 5. So y would equal negative 4. Okay. But remember that when we're solving a system, we're not just looking for the x value or the y value. We have to find both. So now that I've found y, I'm going to take that y value and plug it back into any one of my equations. And I could use one of my originals, or I could use this one that I rewrote here. And that's actually probably my easiest because that's set up in a way that's going to tell me what x equals. X equals blah, blah, blah. So I can just write in x equals negative 4 plus 5, and negative 4 plus 5 is equal to positive 1. When I go to write my ordered pair, remember x always comes first. So my coordinate here would be 1 comma negative 4. And that's my answer for number 11. Okay. Number 12, I'm going to show you with elimination. Now again, you could go back and use substitution just like we just did. But I kind of wanted to show you both so that you could feel free to move between the two and use the one you were most comfortable with. Okay, remember with elimination, I need to find some way to get either the x's or the y's to cancel out. And here, if I'm looking at my x's, I have a 3x and a 6x. And I would love it if I could take that 3x and turn it into a negative 6x because that's what would cancel with a 6x. To do that, I'm going to multiply the bottom equation by negative 2. Okay. And again, I'm just choosing a number that would make it so that either my x's or my y's would cancel out. So here's what that equation would look like if I multiplied everything by -2. This would be -6x. -2 times -y becomes +2y. And don't forget to multiply this number down on the end as well. So that would become -8. And I'm just going to take this top equation and rewrite it down here so that you can see them next to each other. So here I have 6x minus 2y equals +8. Okay, so my x's cancel out, and I know that because I designed it that way. I made it so that my x's would cancel out. But I want you to notice here what happens with the y's. Here the y's cancel out as well. Now normally that doesn't happen. Normally you have a y value left. But this is a strange case where the y's are going to cancel out as well. And go figure, your last numbers are going to cancel out as well. Everything cancels out here. Okay? This is a unique situation that happens from time to time. So what I'm really left with here on this left side is 0. And what I'm left with here on the right side is 0. Okay? And we talked about this situation a few times in class. If you're left with an expression where you have two of the exact same numbers equal to one another, that means that you have infinitely many solutions. Infinitely many solutions. And what's really going on here is, remember, when you're finding that solution, you're finding the point where the two lines cross. In this situation, if you were to graph both of these lines, one line would actually lie right on top of the other. So they would cross everywhere, okay? The entire line would be an intersection point. And so that's why we would say that that's infinitely many solutions, okay? Now, if this had worked out to where this side canceled out and you were left with a 0 here, but you still had numbers left over here, if these numbers did not cancel out, so you would end up with 0 equals something, that would be no solution. If you end up with a statement where you have two numbers that are not equal to one another, you would say no solution. Okay? And we'll talk about what that means in terms of a graph, I think, on the following page. Okay, let's take a look at problem number 13. Problem number 13 is asking you to solve. Remember, solving is like unwrapping a present. Right? You're doing everything backwards. So we want to undo everything, and we want to do it in the reverse order that you would normally do a problem in. Okay? So I want you to think about PEMDAS for a minute. Remember, PEMDAS is order of operations. Okay? So if I look at this problem, I see multiplication, I see an exponent, and I see addition. So I have exponent, I have multiplication, and I have addition. To solve this problem, to undo it, I'm going to work in reverse. So I'm going to go in this order and undo the problem to get to x. I'm trying to get x by itself, so I'm going to get rid of everything else. So the first thing I'm going to undo is the addition. I want to get rid of this plus 5. And to do that, I would use a minus 5. Now, we don't always get this technical every time we solve equations, but I see a lot of mistakes here because people want to try to undo that exponent first, right off the bat. And you can't do that because when you're equation solving, you work in reverse order. So I'm pointing this out here so that you can see why we're doing things in the order that we are. So that would leave me with 3x squared equals 48. And again, I'm still not ready to get rid of that square because I still have this 3 here. So I got rid of my addition. Now I need to get rid of my multiplication. And the opposite of multiplication is division. So I'm going to divide by 3. So I end up with x squared equals 16. Now finally, I'm ready to get rid of that exponent. So the way you get rid of a square is by using a square root. So I'm going to take the square root of both sides, and that would leave me with x equals. Now be very careful here as well, because in your calculator, when you type in the square root of 16, it's going to tell you that the answer is 4. But remember, we talked about this in class, that every number really has 2 square roots. Your calculator only tells you 1, so you have to be smarter than your calculator. Okay? Your calculator tells you the answer is 4. You need to know that that's really plus or minus 4, which means your answer could be positive 4 or negative 4. If you leave off that plus or minus, your answer is not correct. So make sure that you remember that. Anytime you take a square root, you'll end up with 2 answers. Okay, 14 is going to work very similarly, and actually 14 is going to take one less step than number 13. I'm going to start by getting rid of that minus 11. So let's add 11 to both sides. So I end up with x squared equals 36. Now that I'm here, just like when I was back here, I'll take a square root of each side. Your calculator will spit out x equals 6. You have to know that it's really plus or minus 6, and that would be your final answer. X could be positive 6 or negative 6. Okay, moving right along on this page. 15 and 16, just want you to write inequalities. Inequalities is when we're using greater than or less than. Okay, so you just need to decide which is which. Okay, so I'm comparing x to the number 2.5. That's what this says right here, 2.5. And since I've shaded to the left, that means that I've shaded everything that is less than 2.5. Okay? And you can always just point this arrow in the direction that your shading is done. And then the only other thing I need to consider is this dot right here. This is a filled in dot. So that means our answer needs to include 2.5, which means in our inequality we need to say it could be less than or equal to 2.5. But otherwise, that's all this question is asking, and I'm sorry you couldn't see that. Could you? Yep, it should be x is less than or equal to 2.5. I apologize for that. Let's try this one, and that will probably clear any questions up that you had about this, number 15. Again, we are taking the x and we are comparing it to 2, because that's where this end point is. Okay. The shading again is to the left, so that means that we have shaded everything less than 2. However, this time, and I'm not sure if you can see it on the video, but you should be able to see it on your own packet, this is an open circle. That means we do not want to include 2 in our answer, so I'm not going to include an equal bar underneath that less than symbol. I would just leave my answer right there. X is less than 2. Okay? All right. Down to 17. 17 is talking about correlation, which again goes back to when we talked about our scatter plot problem. Okay? With correlation, you are always giving a number between -1 and 1. So you could have -1, you could have 0, you could have 1, and you could have anything in between as well. Okay? Correlation is a measure of how closely your dots are to being in a perfect straight line. So if they were in a perfect straight line and they were headed up, they were headed in a positive direction, the dot sloped this way, that would be a +1 for their correlation. If they were in a perfect straight line but they sloped downward like this, that would be a -1. And if they weren't in a line at all, the correlation would be 0. So for all of these, you are just estimating where the correlation falls between -1 and 1. For this first one, I can see that the line is sloping up. It's a real slow slope, but it is sloping up, so it's a positive number somewhere. And I would say that that's pretty close to being in a straight line. So you could actually just say that this correlation is about equal to 1. Now, if you tried to estimate it and you said it was maybe 0.7 or 0.8, that would be perfectly fine too if you actually tried to pick a number in between here. Really, I just want you to know the difference between these graphs and how they fit on this scale. So if you did an estimation, that's okay, but this is really all I was looking for. If I look at letter B has no shape of a straight line. There's no line that I can find in here anywhere. So I would say that correlation is 0, which would indicate that it does not make a straight line. For letter C, we're pretty close to being in a straight line, except this time we're sloping downward. That means that this correlation would be about equal to -1. Okay, and again, if you had said -0.9 or something along those lines, that's perfectly fine. Now for this next one, we are going to have to estimate a little bit. It's certainly more of a line. There's certainly more of a trend towards a line than, like, let's say letter B, but it's not really close to being in a straight line itself. It does slope upward though, so I know I'm dealing somewhere with the positive numbers. I would call this one probably about 0.5, somewhere like halfway in between. But again, this is just asking for you to estimate. It's asking for an approximate correlation. So if you had said 0.4 or 0.6, that would be perfectly fine too. Okay, that does it for this page of your second review packet for the Algebra 1B exam. And I hope that was very helpful to you, and we'll pick up with the next page in just a few minutes.